So this is the lesson that was taught to A group on Tuesday, November 3rd. So that'd be yesterday. Sorry I didn't get this posted earlier. I'm going to try to do better at posting things the day before I teach them. But here it is, 6.3, simplifying square roots using the quotient property. The other day we talked about using the product property. Today we're talking about quotient property. Product is two things being multiplied. Quotient is two things being divided. So we saw this on the previous notes for the product property, but I wanted you guys to see it again. For the product property, we mainly focused on this first condition because it says a radical expression is an expression that contains a radical. An expression involving a radical with index n is in simplest form when these three conditions are met. No radicands have perfect nth powers as factors other than 1. So, like I said, when we were doing the product property, we were using that first condition. We were taking out all the perfect squares from underneath our radical to make it in simplest form. Today, for the quotient property, we're going to mainly focus on this second condition. No radicands contain fractions. If you remember, this little number right here is our index. The number under the radical is our radicand. So we just want to make sure that there are no fractions inside of our radical. So that's what we're dealing with today. So here's our quotient property. In words, the square root of a quotient equals the quotient of the square roots of the numerator and denominator. So just looking at that visually with an example, the square root of 3 over 4 right here. It's kind of similar to our product property. It just states that we can split our numerator and our denominator into their own square roots. So the square root of 3 over 4 becomes the square root of 3 over the square root of 4. And then I can simplify both of my radicals. Square root of 3 cannot be simplified any further. Square root of 4 just becomes 2. So my simplified radical is the square root of 3 over 2. And here's our algebraic way of looking at it. Square root of a over b equals the square root of a over the square root of b, where a is greater than or equal to 0 and b is greater than 0. So that's all we're doing today. Giving our numerator its own square root, giving our denominator its own square root, and then simplifying both square roots in the numerator and the denominator. So let's look at some examples. Square root of 15 over 64. My first step will be to split them up into their own radicals just like this. That's my quotient property right there taking place. Giving my numerator its own square root, my my denominator its own square root. Now I just simplify both radicals. Square root of 15 is already in simplest form because there are no perfect squares that can go into 15. So it just stays as the square root of 15. Square root of 64 is just 8, so it just simplifies down to 8. Now the square root of 15 over 8 cannot be simplified any further. And based on my three conditions from the very first slide, there's no perfect squares that go into my number under the radical. I no longer have a fraction inside the radical, and I do not have a radical in the denominator. So this is my radical in simplest form. So once again, split them up into their own radical, simplify both radicals. Let's look at number 2. Square root of 81 over x squared. Once again, our first step is to break it down to have our numerator under its own square root, the denominator under its own square root. Simplifying each radical, I'm asking myself, what's the biggest perfect square that goes into 81? Well, 81 is a perfect square itself. I can take the square root of it. Square root of 81 is 9, because 9 times 9 gives me 81. Whenever we did the product property, we saw some variables. So if you remember back from those notes, I can take the square root of x squared. Square root of x squared is just x, because x times x gives me x squared. 9 over x cannot be simplified any further, so that is my answer, 9 over x. I'm hoping this is making sense. It's a little easier than the product property, but it can combine the product property whenever we're simplifying our square roots. So let's look at some more examples. Square root of 23 over 9. First step, break it down into their own square roots. Square root of 23 cannot be simplified any further. There's no perfect squares that go into it. Square root of 9 is 3. I cannot simplify the square root of 3 over 3 any further, so that is my answer. That one was pretty easy. Now let's look at number 6. I've got this negative outside my square root. That doesn't really change anything for me. It just kind of stays outside here. So once again, I break them down into their own square roots. Square root of 17 over the square root of 100. And now simplify each square root. Don't forget about your negative. That has to stay there. Now you're asking yourself, what's the biggest perfect square that goes into 17? There are no perfect squares that go into 17, so that is in simplest form. Square root of 100 is 10. So my final answer is the negative square root of 17 over 10. Just like that. If this isn't making any sense, feel free to ask questions on Canvas or through email. I'll try to respond as quickly as possible. Let's move on to number 7. So we have the square root of 36 over z squared. Break them down into their own square roots. Square root of 36 over square root of z squared. Simplify each radical. Square root of 36 is 6. Square root of z squared is z. 6 over z is my answer. And then our last example. Break them down into their own square roots. So I get the square root of 4x squared over the square root of 64. Simplifying both radicals. Square root of 4 is 2. And the square root of x squared is x. So I'm just taking the square root of both things in my numerator. So in my numerator I get 2x. Square root of 4x squared gives me 2x. Square root of 64 is 8. Now don't stop there. We always want to make sure our fraction is in simplest form. This fraction that we got is not in simplest form. If I have 2x over 8, 2 and 8 are both divisible by 2, so I need to go ahead and do that. 2 divided by 2 is 1, so I get 1x. 8 divided by 2 is 4, so I just get 1x over 4, or just x over 4 for my answer on number 8. Like I said, I'm hoping this is making sense. I feel like the quotient property is a little easier, especially to start off with, than the product property. So you're just splitting the numerator into its own radical, denominator into its own radical, and then simplifying both square roots. So the homework for this is page 297, numbers 21 through 28 all. It's only 8 problems. I think I told A group this will be due on Friday. So this will be due Friday. That'd be November 6th on Canvas. So you'll upload it onto Canvas. Like I said, if you have any questions, please let me know. Y'all have a good rest of your day.